all the planets of the solar system are slowly lining up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Neptune are about to form a straight line. This event, called the Parade of Planets, occurs once every 176 years. The last time this happened was almost 40 years ago, and it was a great chance to explore all these planets in one go. On August 20th, 1977, thousands of people gathered outside NASA's Kennedy Space Center. They came to witness the launch of the most ambitious and distant space mission in history. 5, 4, 3, 2, 1, ignition! Launch rocket Titan took off from Earth and left the atmosphere. As soon as the rocket reached outer space, it launched the probe Voyager 2, which began its journey. The probe consisted of a bus 1.5 feet in height and almost 6 feet wide. On top of it, there was a round 12-foot wide antenna. Most of the scientific equipment was mounted on a boom that extended 8 feet outward. On September 5, 1977, Voyager 1, the identical space probe, left our home planet. It sent us pictures of Earth and the Moon. It soon overtook Voyager 2, launched 2 weeks earlier. That's why the second probe has the number 1 in its name. And so the journey through dark space began. March 5, 1979. About 4 Earth-Sun distances away from our planet, Voyager 1 came close to Jupiter and prepared its scientific equipment to explore the planet. The probe had a dozen gadgets, including a 2-camera system with narrow and wide-angle lenses. So, it could take full-length photos of the planet with the wide-angle camera, as well as close-up photos of specific places on the planet and its satellites. The probe also had a radio science system to determine the atmospheric composition, weight, and gravitational fields of the planets it came across. Infrared and ultraviolet spectrometers could help measure radiation and temperature invisible to the human eye. Various sensors were used to examine cosmic rays. Voyager 1 was the first to find volcanoes outside Earth. Those were on Jupiter's satellite, Io. It has dozens of active volcanoes that constantly spew lava. Then the probe pointed its cameras at the Great Red Spot. That's how people learned that it was a giant cyclone-like storm that hasn't stopped for the entire history of observations of Jupiter. It was also the first time when lightning was detected outside of our home planet. And in the invisible spectrum, Voyager 1 noticed that Io acted like an electrical generator for Jupiter. Ions, which are charged particles, were constantly flying toward the gas giant. This electrical current was 5 million amps. Soon, Voyager 1 continued its journey. 5 months later, Voyager 2 approached Jupiter too. This gas giant has rings around it. They're not like Saturn's though. Jupiter's rings consist mostly of dust. When the planet's rocky satellites collided, they turned into small debris. Gradually, this debris turned into fine dust. Then Voyager 2 approached Europa. This moon is completely covered by a crust of ice, and beneath it, there may be a liquid ocean where life can possibly exist. Voyager 2 was the first to capture the cracks in Europa's ice crust. While flying near Io, Voyager 2 discovered that 6 volcanoes on its surface were still erupting. This meant that the periods of activity of these volcanoes could last for months. Both space probes circled the gas giant several times and then dashed further into space. Such a gravitational maneuver allowed them to gain more speed and saved fuel for the trip. By November 9, 1980, Voyager 1 had already traveled 8 Earth-Sun distances away from home. The space probe arrived at Saturn. It discovered 3 new satellites of the gas giant: Atlas, Prometheus, and Pandora. This proved the theory that these were the moons that kept the planet's rings in line. It also turned out that unlike Jupiter's, Saturn's rings also contained ice. Voyager 1 took a peek at Titan, Saturn's largest satellite. It's 50% larger than the Moon and even has an atmosphere. It's the only place in the solar system besides Earth where liquid water has been proven to exist. That's why scientists don't deny the possibility of life there. Then it was time for another gravity maneuver. Voyager 1 once again darted away from the planet's orbit. This time, it was aiming upward relative to the line of the Parade of Planets. Almost a year later, Voyager 2 arrived there. It made a flyby of several of Saturn's icy satellites. Supposedly, A long time ago, these moons collided and knocked huge chunks of ice and rock out of each other. This debris orbited Saturn, collided, and slowly crumbled into dust, consisting of ice and rock. This is how the famous rings of Saturn were born. Another gravity maneuver, and Voyager 2 set off for the next gas giant. 5 years later, it arrived at its destination, 17 Earth-Sun distances away from our planet. For the first time ever, a human-made object approached Uranus. Voyager 2 discovered 11 new moons there. The probe also found that Uranus was the coldest planet in the solar system. Its temperature is negative 350 degrees Fahrenheit. That's 4 times colder than the temperature at the South Pole. At that time, the Deep Space Network was being tested on Earth for the first time. It's a network of radio telescopes all over the planet. They aim at certain points in the sky to establish communication with extremely distant objects. These telescopes have been successfully receiving signals from Voyagers 1 and 2. August 25, 1989. Voyager 2 had already traveled 23 Earth-Sun distances and arrived at Neptune. It was the first time people received images of this blue planet from such a close distance. The probe discovered 6 new moons there and also took the first pictures of the planet's rings. Engineers then turned off the probe's cameras to save power for its main computer and the instruments that measured the solar and interstellar wind. Voyager 2 left Neptune and headed into deep space. That's why it no longer needed the cameras. A few months later, Voyager 1 sent its last photo back to Earth. It was a family portrait of our entire solar system. Every pale dot was a planet. You can barely recognize Earth in the picture. After that, the camera was turned off to save power. This was the start of the interstellar mission for Voyager 1. For 15 years, Voyager 1 had been flying to the edge of the solar system. On December 16, 2004, the probe passed through the termination shock. This is where the solar wind suddenly slows down and heats up after colliding with the interstellar wind. The space probe managed to endure this test and continued its journey. In 2007, Voyager 2 crossed the same boundary. At that point, sensors recorded a temperature of about 266 degrees Fahrenheit, but the probe managed to withstand it and continued its journey through the dark cosmos. Both Voyagers moved through interstellar space in different directions. They discovered that the heliosphere, the solar wind bubble, is not perfectly round, but more like an egg. August 25, 2012. Voyager 1 became the first human-made object to enter interstellar space. It's now also the most distant artificial object in human history. On November 5, 2018, Voyager 2 also left the solar system. The 2 probes continued their journey into deep space. Right now, the Voyagers have been operational for 44 years. Voyager 1 has traveled 153 Earth-Sun distances and is moving forward at 38,000 miles per hour. In about 300 years, the probes will reach the Oort cloud. This is a hypothetical region around the solar system with nothing but asteroids and blocks of ice. Scientists believe they might reach the nearest stars in the next 40,000 years. Perhaps one day, the Voyagers will enter these star systems and explore unknown worlds. There may be planets there that look like ours. The probes may even be able to find an intelligent civilization there. For this purpose, each Voyager carries a golden record with a message on it. There are 115 images. Among them, there's our number systems, a map of the solar system and pictures of its planets, diagrams of human DNA, portraits of people, and landscapes from Earth. There's also greetings in 55 of Earth's languages, including the oldest and newest of them. There are also 90 minutes of music from every corner of our planet. The Voyagers also carry a device to play these sounds. If another civilization gets this record, their scientists could decode the data step by step. And then, that civilization may decide to pay us a friendly visit. They'll have to repeat the heroic journey of the Voyagers, though. Dozens of light years through dark space. Then crossing the border of the solar system, and finally flying past Neptune, Uranus, Saturn, Jupiter, Mars, and the asteroid belt toward the little blue planet. We can only hope that people will be advanced enough to welcome them.
3, 2, 1, 0.
In 1977, NASA sent the Voyager spacecraft to explore the outer parts of the solar system and the space beyond. And at one point, the probes ran into something totally nightmarish: a blazing wall of fire, measuring temperatures from 54,000 to 90,000 degrees Fahrenheit. Well, did the probes manage to survive these intense conditions? We'll find out soon. Meanwhile, there are several ways to think about where the solar system ends. One way is to say it ends where the planets stop. Another way is connected to the Oort cloud. That's a giant group of icy objects far beyond the planets, the farthest region of the solar system. It is extremely distant, maybe a quarter to halfway to the nearest star. To understand such huge distances, scientists often use something called the astronomical unit, or AU. 1 AU is the distance between Earth and the Sun. For comparison, Pluto orbits between about 30 to 50 AU from the Sun. The inner edge of the Oort cloud is thought to be much farther away, and the outer edge could be even further away. These distances are very hard to imagine. My little brain sputters when considering such. Now, we can also measure them in time instead of miles. NASA's Voyager 1 spacecraft makes almost 1 million miles per day. At that speed, it would take about 300 years to reach the Oort cloud and maybe 30,000 years to reach its outer edge. Now, one more way to define the edge of the solar system is by the Sun's gravity. It might be the area where the Sun can still pull objects back toward it. And finally, we can define it by considering the heliopause, the boundary where the Sun's influence ends. You see, the Sun constantly sends out charged particles in a flow called the solar wind. This wind moves past all the planets and reaches about 3 times the distance to Pluto. The solar wind creates a giant bubble around the Sun and planets called the heliosphere. The heliopause is the outer edge of this bubble, where the solar wind meets the wind coming from other stars, called the interstellar wind. Here, the pressures from the solar wind and the interstellar wind balance each other. This causes the solar wind to turn back and flow along the tail of the heliosphere. As the heliosphere moves through space, it creates a bow shock, similar to the wave that forms in front of a ship moving through the water. So, depending on how you define it, by planets, by the Oort cloud, by gravity, or by the Sun's magnetic influence, the edge of the solar system can mean very different distances. But if we talk about the Voyagers, they came across something intense. It was something we could probably call a wall of fire. Blazing heat and intense temperatures. The 2 probes became the first spacecraft to travel beyond the heliosphere and cross the heliopause. Before the Voyager spacecraft reached the heliopause, scientists did not know exactly where this boundary would be. But the fact that the 2 spacecraft crossed it at different distances helped confirm some predictions about the heliopause. Scientists did expect that the edge of the heliosphere could move as the Sun's activity changes, a bit like a lung expanding and contracting as we breathe. And the fact that Voyager 1 and Voyager 2 encountered the heliopause at different distances matched this expectation. The heliopause is not a hard edge or solid wall, but the nickname Wall of Fire actually matches the nature of that insane region. Both spacecraft measured extremely high temperatures there, around 30,000 to 50,000 Kelvin, or 54,000 to 90,000 degrees Fahrenheit. Despite these extreme temperatures, the spacecraft were safe. The particles in this region are very far apart, so collisions are rare and not enough heat could reach the spacecraft to harm them. Nearly 50 years after their launch, Voyagers 1 and 2 continued to send back data from beyond the heliopause. They are the only 2 spacecraft that have crossed this boundary so far. Together, they have already made several curious discoveries about space outside the solar system. For example, Voyager 2's magnetic field measurements confirmed a surprising result from Voyager 1. Just beyond the heliopause, the magnetic field lines are aligned with the magnetic field inside the heliosphere. Before Voyager 2, scientists only had one measurement from Voyager 1, so they could not be sure whether this alignment was real or just a coincidence. Voyager 2 confirmed that the alignment was real. The magnetic fields inside and just outside the heliopause apparently run in parallel. These discoveries give scientists important information about the structure and behavior of space beyond the solar system. Now, let's dig a little deeper into the Voyager program itself. It's made up of 2 spacecraft, Voyager 1 and, wait for it, Voyager 2. Even though Voyager 2 was launched first in August 1977, Voyager 1 took off just 2 weeks later on a faster, more direct path. These 2 spacecraft have been traveling for more than 40 years, exploring worlds no human will ever walk on, at least in the near future. The 2 Voyager spacecraft are nearly identical. Each has a large radio dish that is 12 feet across. This dish sends data back to Earth. They also have 16 thrusters to control their direction and make sure the dishes always point toward our planet. The thrusters use special hydrazine fuel, and the spacecraft's electronics are powered by thermoelectric generators that run on plutonium. Each Voyager carries 11 scientific instruments. About half of them were made specifically to study planets, and most of those are now turned off. The turned-off instruments include several cameras, spectrometers, and 2 radio-based experiments. During their long journeys through the solar system, the Voyagers took tens of thousands of images and measurements. This data has changed what we know about the outer planets. When the Voyagers reached Jupiter, they gave us our first detailed look at the planet's atmosphere. They showed that the Great Red Spot was a huge storm spinning counterclockwise and interacting with smaller storms nearby. The Voyagers also discovered a faint dusty ring around Jupiter. They studied Jupiter's moons, too. They found volcanoes on Io, saw linear features on Europa that hinted at a hidden ocean beneath its icy surface, and confirmed that Ganymede is the largest moon in the solar system, larger even than Saturn's moon Titan. Next, the spacecraft flew past Saturn. They measured the planet's atmosphere and studied its famous rings, discovering gaps and waves we still see today. Voyager 1 looked through Titan's thick haze and suggested that the moon might have liquid hydrocarbons on its surface. It was later confirmed by other missions. Voyager 1 also found 3 new moons orbiting Saturn: Atlas, Prometheus, and Pandora. So that's where she ended up. After Saturn, Voyager 1 continued out of the solar system, while Voyager 2 headed toward Uranus. Voyager 2 discovered 11 new moons and 2 new rings there. It also observed strange features, such as Uranus's unusual magnetic field and a surprisingly small temperature difference between its equators and poles. Voyager 2's final planetary stop was Neptune. It happened 12 years after leaving Earth. There, it discovered 6 small moons and rings around the planet. It studied Neptune's atmosphere and magnetic field, and observed volcanic vents on Triton, Neptune's largest moon. After this, Voyager 2 joined Voyager 1 on its journey toward interstellar space. Voyager 1 entered interstellar space in August 2012, and Voyager 2 joined it in November 2018. These missions helped scientists measure the edge of our solar system, about 11 billion miles from the Sun. The spacecraft still sends back data about this mysterious region. By the way, after its planetary visits, Voyager 1 took the famous pale blue dot photo of Earth from about 3.7 billion miles away. Today, Voyager 1 is about 15.8 billion miles from Earth, and Voyager 2 is about 13.1 billion miles away. Each Voyager carries a golden record, a time capsule from Earth for other civilizations it might meet. The record covers include instructions for playing it, a map showing Earth's location, and a drawing of a hydrogen atom. The records are cleverly plated with uranium, so the decay of the uranium could help discoverers figure out when the record was made. The records contain 115 images showing Earth, humans, animals, plants, and our solar system. They include natural sounds like waves and birdsong, greetings in 55 languages, brainwave recordings, and a mix of music, ranging from Beethoven to Chuck Berry and folk songs. Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists use these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky. Folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025, but eventually we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud, and in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. The system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fall protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments. On August 20th, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters that was used to communicate with Voyager 2 hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the eighth planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the two facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon. Mission status critical. The spaceship has hit a wall of fire somewhere past Pluto, where you'd expect to see nothing but total silence and icy darkness. The temperatures here reach 30,000 to 50,000 K. That's hotter than most stars. Yet there is no oxygen or actual flames. Is this the edge of our cosmic home brewing heat? Let's dive right in to find out. The Voyager probes launched in 1977 to explore all the planets. But their journey didn't end there. They kept going and became the first human-made objects to leave the solar system. Voyager 1 passed the heliopause in August 2012, and Voyager 2 followed in November 2018. The heliopause is like a cosmic finish line. It's where the sun's solar wind, charged particles streaming out, finally loses its fight against all the interstellar stuff. When Voyager crossed that line, instead of cold emptiness, scientists found scorching hot plasma. Like I said, there's no flame, just super-fast particles crashing into each other in ultra-thin plasma. They generate crazy temperatures with almost no heat transfer. Voyager 1's plasma detector failed back in the 1980s, but two other instruments recorded a sharp drop in solar particles and a surge in cosmic rays. Plus, there was a big distortion in the magnetic field. By the way, scientists expected the magnetic field direction outside the heliosphere to flip, but there was another surprise waiting for them. Voyager saw it aligned perfectly with the Sun's magnetic field inside. Same alignment, just outside. Voyager 2 confirmed this wasn't a fluke. So, what's causing this alignment? Scientists think it's about how the interstellar field drapes around the heliopause, like wrapping cloth. It matches the Sun's halo as they meet. Models show that in certain areas, magnetic reconnection, where magnetic lines break and reconnect, helps twist the interstellar field to line up with the solar one. Voyager 2 revealed that the outer region is actually denser and colder than the heliosphere, and the particles from inside are slipping through into space, like leaks in a cosmic ship's hull. As for Voyager 1, it even helped solve a cosmic ray mystery. Models thought Particle counts would peak at the heliopause. But Voyager saw something the scientists called the Voyager paradox. It turns out that our solar system doesn't have a clean, empty edge. It has a shockingly hot, magnetic, and complex boundary where the sun's influence meets the galaxy. Voyager has proven that space isn't just static and cold. It's dynamic, turbulent, and unpredictable. We've cracked open the curtain and peeked at the weirdest frontier humans have seen. And we're still not even halfway through the story. Voyager 1 started acting strange back in November 2023. Its flight data system, which is like the spacecraft's brain, started sending a repeating pattern of gibberish. Normally, this system bundles up all the science data and engineering stats, like temperatures, voltages, and the spacecraft's heartbeat, and sent it to Earth in ones and zeros. But suddenly, the messages made no sense. Voyager 1's radio signal still reached Earth, but it was a steady "I'm alive" ping without any useful info. After months of trial and error, they discovered the culprit, a single, stubborn memory chip that had gone rogue and corrupted about 3% of the system's memory. Nobody knows why it failed. Maybe it was just worn out after 4 decades, or a high-energy particle from deep space hit it like a cosmic bullet. Since they couldn't replace the chip, NASA engineers had to pull off some scientific magic to fix this 46-year-old gadget. They divided the missing code into pieces and carefully moved them to other memory spots on the spacecraft. A radio signal takes 22.5 hours to reach Voyager 1, and another 22.5 hours to come back. So, NASA engineers were sending messages into the void and waiting almost 2 full days to see if it worked. On April 20th, Voyager finally responded with readable, coherent data. It was like getting a text back from a friend who's been ghosting you for months. Except this friend is 15 billion miles away, floating at the edge of the solar system. Voyager 1, as well as its twin Voyager 2, was originally meant to last only 5 years. Both have gone through many challenges over their long journey. For example, a 7-month blackout in 2020 for Voyager 2, and a 2023 antenna mishap that required a shout command to get it pointed in the right direction. But despite all that, they're still working hard and sending back extremely important data. Voyager 2 zoomed past Uranus back in 1986 and sent us pictures and data from billions of miles away. After looking at that data, scientists thought Uranus wasn't giving off much heat, which is weird for a giant planet. But now, thanks to years of spacecraft observations and fancy computer models, researchers have found Uranus does have its own internal heat. It's just subtle, only about 12.5% more than the sunlight it gets. That means the planet is slowly shedding leftover heat from its birth, like a giant cosmic radiator cooling down after a superhot childhood. Its long 20-year seasons and tilted spin make the heat fluctuate. Figuring this out helps scientists understand how planets form, how atmospheres behave, and even give hints about Earth's climate. Voyager 2 might have just shown us a frozen, quiet world, but decades later, that data helped uncover a secret heartbeat under Uranus's icy blue clouds. As you can see, space loves plot twists. Let's hop to Saturn's tiny moon, Enceladus. Scientists believe there's a massive ocean hidden under its frozen shell, and this moon's core is keeping it warm. Enceladus is small, about the width of Arizona, but it's one of the most promising places to look for extraterrestrial life. And that's because NASA's Cassini spacecraft caught it, spitting. Giant geysers of water were shooting out from cracks in its icy surface. Not only plain water, though. These plumes contain salts and organic molecules, including carbon, hydrogen, nitrogen, sulfur, and oxygen. These are the building blocks of life. And then, they also found phosphorus there. It's the rarest of the 6 elements upon which life depends. Together with sugars, it forms a skeleton for DNA molecules. The amazing part is that the concentrations of phosphorus on Enceladus are at least 500 times higher than the highest known concentrations in our oceans. Scientists also study the ice from Enceladus. plumes of water vapor freeze into snow on the surface here, and they found it might not be all shapeless dust like they thought. Up to a quarter of this ice can form tiny crystals, hiding like chocolate chips in cookie dough. They ran simulations, froze virtual water at crazy speeds, scrambled molecules, and even tested real ice with X-rays. Some ice is so odd that it has the same density as liquid water, so it neither sinks nor floats. It's all critical to know, as space ice could shield spacecraft, serve as fuel, or even show how building blocks of life travel to Earth. Scientists haven't found life or something life might have created on Enceladus yet. But it looks like if we find life anywhere in our solar system, this moon will be the first in line. Or maybe we'll hear some exciting news from the Voyagers before it happens. They are still out there right now, flying through interstellar space. And some people are worried they could get damaged when they finally pass through the Oort cloud. Scientists haven't seen it directly, but many comets that visit us come from that region of space, stretching far beyond the Kuiper belt. The astronomer who supposed the cloud was real said it could contain around 100 billion comet-sized objects. Their total mass could be as heavy as Earth's. Sounds dangerous to the Voyagers, but no worries. Scientists say the odds of them getting damaged are 100,000 times lower than your chances of winning a lottery jackpot. Oh well. So the Voyagers will keep sending faint signals for a few more years before their power runs out. After that, they'll just keep traveling.
NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the Sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the Sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the Sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The Sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the Sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the Sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space, who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
5, 4, 3, 2, 1.
Ah, Saturn. Incredible with its majestic rings and swirling clouds. But what would it be like to dive into it? NASA's Cassini tried that, and it turned out to be a wild trip. NASA's Cassini spacecraft was a probe that spent 13 years orbiting Saturn and gathering some incredible data. One of its major goals was to help us understand how come Saturn's atmosphere is so hot. The upper atmospheres of planets are always heated, duh. They're directly under the sun. The strange thing about Saturn is that gas giants are too far from the sun to get that kind of warmth. So Cassini didn't just observe the planet from outside. On September 15, 2017, it dove deep to the journey that would become the spacecraft's grand finale. Its last moments were spent inside Saturn's upper atmosphere, sending back priceless data as it slowly disintegrated. Now, these upper layers are no joke. The planet's horrifying magnetic field hums with energy, and powerful winds whip around at thousands of miles per hour. Cassini would pass through thick layers of clouds, hazy, pale gold, and muted, reflecting the sun's faint light. And these aren't cute, fluffy Earth-like clouds made of water vapor. This is a nightmare cocktail of hydrogen and helium. The probe ventured deeper, passing through the region where Saturn's iconic rings rain material onto the planet. Cassini discovered that this rain was more intense than anyone expected, more than 22,000 pounds of material per second. That's at a rate that Saturn's rings might not last forever. The planet's own gravity could eat them away completely someday, unless the rings get a sudden update. These are all tiny grains of ice and dust, caught in the planet's gravity, falling into the atmosphere like a relentless storm. The grains, mixed with water, methane, and even chemicals like propane and butane, slowly alter Saturn's atmospheric chemistry. It mixes with the particles in the planet's upper atmosphere, making them heavier and warming Saturn up. Unfortunately, this was too much for poor little Cassini. It was designed to be tough enough for the outer layers, but it burned up before it could descend into the terrifying deeper regions. In the more intense layers of Saturn's atmosphere, winds reach extreme speeds of over 1,100 miles per hour. The pressure becomes crushing, and the deeper you go, the more overwhelming it becomes. It would feel like entering an ocean of gas, one with no clear surface, where the sky gets darker, thicker, and more hostile as you descend. And at a certain point, complete darkness. Just you and the overwhelming mass of hydrogen gas pressing in from all sides. But Cassini's sacrifice was invaluable to scientists. The key data it sent us before the grand finale allowed scientists to map Saturn's upper atmosphere more completely than ever before. Cassini tracked bright stars, like those in Orion and Canis Major, as they passed behind the planet, measuring how their starlight shifted. This helped scientists to understand how dense and hot the atmosphere was. It left us some final pictures as well, though they're not as impressive as you might think. It was a monochrome shot taken from about 394,000 miles away, showing a dark portion of Saturn's night side, softly illuminated by the reflection of its own rings. NASA also posted a picture made by their own artists of what Cassini could have seen in its last moments. And of course, it gave us the answer to the big mystery of Saturn's heat. It's because of auroras. It turns out that due to the crazy magnetic field, the planet's cloud layers are sparked up by sudden bursts of auroras at the poles. They're like the northern lights on Earth, but far more intense. The gas giant skies occasionally light up with radiant greens and blues. They're sparked by the interaction between solar winds and the charged particles from Saturn's moons. The hottest areas of Saturn were near these auroras. These light shows are powerful enough to heat the upper atmosphere, spreading warmth across the planet. Thanks to this added information, we discovered something important, not just about Saturn, but about all gas giants across our solar system and beyond. Meanwhile, the photos we have of Venus are much more dramatic. Venus is a bit closer to the Sun than Earth. It's often been called Earth's twin because of the similarities, like in size, mass, and composition. But don't be fooled. Beneath those thick clouds lies one of the most toxic environments in our solar system. Its surface is a nightmare, where temperatures soar to about 900 degrees Fahrenheit, hot enough to melt lead. The pressure on the planet is crushing as well, 92 times that of Earth's. That's like standing 3,000 feet under the ocean. We just couldn't resist taking some pictures. So, in the 1970s, scientists managed to land probes on this volcanic, unforgiving surface. And these missions were successful. They managed to send back the first photos of Venus and showed us incredible stuff. The first probe lasted only 23 minutes on the surface and then crushed down under this crazy pressure, winds, and heat. Both first and second probes captured black and white panoramas of a rocky hillside. On both, the second lens failed to eject. The horizon was flat, the ground strewn with jagged rocks, and the oppressive atmosphere pressed down like an invisible force. After lots of hurdles, we finally managed to look at colorful pictures from Venus in the 1980s. This spacecraft lasted more than 2 hours after extreme conditions. It's incredible that they managed to send us anything at all. Venus is a planet where metals melt, and where the atmosphere itself eats away the spacecraft. The photos it took showed that on Venus, the skies aren't blue, but an eerie yellow due to the thick clouds of sulfuric acid. NASA also has some computer simulations of what Venus's surface could look like, but these don't really convey the horror of actually being there. Perhaps it's time we look at Venus once more. There's so much we don't know about this fiery neighbor. Finally, we also tried to enter Jupiter's atmosphere in the 90s, and that's the hardest one on the list. NASA's Galileo missions probe was designed to dive into Jupiter. It was launched in 1989 and traveled millions of miles with a small entry probe on board. This tiny hero would face one of the most intense environments we've ever encountered in space. It was finally released on July 13, 1995. At that moment, the spacecraft was still 50 million miles away from Jupiter, so just to enter the atmosphere, it had to fall for months. And it finally did fall on December 7th, plunging headfirst into Jupiter's thick, swirling atmosphere. The probe slammed into Jupiter's skies at a staggering 106,000 miles per hour. That's fast enough to cross the United States from Los Angeles to New York in 90 seconds. The intense deceleration caused the probe to experience a horrifying gravity, 228 times stronger than the Earth's. It slowed down from supersonic speeds to just 100 miles per hour in minutes. The heat generated by its entry was so extreme that the shock wave ahead of it glowed as brightly as the sun itself. The temperature soared to 28,000 degrees Fahrenheit. And all this time, somehow, the probe was collecting data every second and sending it all to us. It gave us some critical information about Jupiter's mysterious atmosphere. For example, it turned out that Jupiter's upper atmosphere was drier than expected, less water vapor and fewer organic compounds than scientists thought. The probe also measured fierce winds of up to a half a mile per second. And surprisingly, it didn't see that much lightning, even though we thought these are never ending on Jupiter. One of the probe's biggest surprises was the discovery that Jupiter's atmosphere contained less helium than we thought. It also revealed a horrifying radiation belt about 30,000 miles above Jupiter's clouds. It's like intense radiation encircles the planet like a cosmic shield. The poor little guy managed to survive for 58 minutes. It eventually succumbed to immense pressure. Meanwhile, the Galileo orbiter continued its mission, becoming the first spacecraft to orbit Jupiter. Dust storms on Mars can really go crazy. They hurtle through the red planet's southern hemisphere, especially during the summer. These storms can grow and encompass large areas of the planet, as happened in January 2022. Then, a dust storm covered almost twice the area of the United States. Could it be something like this that caused one of the robots we sent to Mars to go missing? The atmosphere and climate are harsh on Mars, It's mostly a desert with strong winds and average temperatures of minus 81 degrees Fahrenheit. It drops down to minus 220 at the poles during the winter. A lander needs to be specifically equipped and very sturdy to withstand such conditions. But researchers thought the Beagle 2 could handle the difficult trip to the Red Planet. June 3, 2003. A team of researchers got one of their pioneering robots they were about to send to space ready. It was a small and compact lander called the Beagle 2. Its mission was to touch down on Mars and search for what the world has been actively looking for decades now: life on the Red Planet. Now, the touchdown was due on December 25th, but the signal never came. The team tried to contact the spaceship, but at one point, they had to accept they wouldn't be able to reach it. Some thought the landing was too difficult and complex after all, so the lander crashed. But they couldn't find any technical errors. Others had a theory that the lander may have become entangled in its own parachute and fell down to the surface of Mars. Either way, the Beagle 2 was considered missing. Until 2015, when NASA took pictures of what could be the remains of the lost lander. They weren't just smashed debris, the components actually looked to be intact. The lander's remains were lying with its solar panels partially deployed around 3 miles away from the site where it was supposed to land. Apparently, the Beagle 2 managed to land successfully, but its radio antenna got blocked. That's why researchers couldn't control it from Earth or communicate with it. But no one knows exactly why it happened. Have you heard of a face on Mars? In the 1970s, one of NASA's spaceships took the iconic images of the Martian surface that showed a face-like formation, as you can see in the upper part of the picture. If you have a rich imagination, you can easily see a nose, 2 eyes, a mouth, and an unusual hairdo. Some even thought it was a monument built on the Red Planet by another civilization. How about some other unusual things people have found on Mars, like Happy Face Crater? You can easily see why it has this nickname. Or rocks in different shapes, a pancake, brachiosaurus, or a fish. Mars also has a waffle-shaped island on its surface. It's a 1.2-mile-wide feature you can see in the area of lava flows. It might be the result of lava pushing this formation from below. It seems astronomers have also got some images of blue dunes. It's a sea of stunning dark dunes that strong winds sculpted into long lines. They surround the planet's northern polar cap and cover a region as large as Texas. The Red Planet is usually known for its brown sandy dunes, so these ones certainly came as a surprise. In reality, though, they're not really blue. If you could visit Mars right now just to take a look, you'd see that these dunes appear brown and orange like the rest. And the picture is a false color image. Scientists often use false colors to highlight differences in something. For example, here it's the difference in depth. Also, the biggest valley on Mars is so large it could eat our Grand Canyon for breakfast. It's a fascinating system of canyons 2,500 miles long called Valles Marineris, and it's over 10 times as long as the Grand Canyon. Now, if you could stretch this Martian canyon, it would go from coast to coast of the entire United States. Since Mars doesn't have any active plate tectonics, no one knows for sure how this canyon formed. One theory says a chain of volcanoes located on the other side of Mars, the one that includes Olympus Mons, bent the crust from the opposite side of the planet. This powerful force caused cracks in the Martian crust as well as activated enormous amounts of water lying under the surface. This water then emerged and carved the rock away. The force activated glaciers too, and they possibly created new pathways in this gigantic canyon system. Volcanoes on the Martian surface could have erupted about 50,000 years ago, although the most powerful eruptions happened 2 to 3 billion years ago. But the planet doesn't have active volcanoes today. Most of the heat stored in its interior during the planet's formation has been lost. So now, Mars's outer crust is way too thick for the molten rock to reach the surface. But a long time ago, eruptions formed giant volcanoes, and these volcanoes most likely had an important role in melting ice deposits, which released floods of water onto the Martian surface. Now, Mars has a thin atmosphere with a volume of gas, mostly carbon dioxide, less than 1% of Earth's. But 4 billion years ago, it was way warmer and wetter than now. Its atmosphere must have been thicker back then too. That's why it could create a powerful greenhouse effect and trap sunlight. Mars also has a powerful magnetic field. Similar to Earth's, it formed because of the currents of molten metals in the planet's core. But unlike our home planet, Mars lost its magnetic field after its core had cooled down. And without it, the planet didn't have any protection from the solar wind, which is a stream of charged particles flowing from the sun. The solar wind pulled away most of Mars's atmosphere in just a couple of 100 million years, give or take. This is what makes those powerful Martian dust storms even more intense. Mars has a fascinating history. Judging by the planet's glaciers, Mars has probably gone through multiple ice ages, just like Earth. A team of researchers got images of about 60,000 Martian rocks. Rocks were different in size and distributed randomly, which means they probably formed during different ice ages. Glaciers hide their own stories too. Who knows what kinds of gases, rocks, or even microbes could be trapped inside? Now, if you could get into a time machine and stop it 4 billion years ago, on Mars of course, the chances are you would see spectacular scenes of flooding. Maybe there would even be some form of life on the planet's surface. A strong meteorite impact that formed the red planet's Gale crater could be something that triggered that mega flood. After that collision, the temperatures on the planet got insanely hot. This caused the melting of all that ice that was stored on the Martian surface at that time. The flooding was so massive, it changed the geological structure of the planet's surface. It carved out big ripples, as well as waves in the sedimentary rock. Now, speaking of water, vapor has been noticed escaping the atmosphere of Mars. Also, researchers have found some evidence of water flowing on the planet's surface. There are dark streaks in the soil. They seem to get bigger in the summer and shrink over the winter. There are numerous dried-out valleys and river channels on the planet. It's possible that liquid water once flowed there. Now, most of it could be locked up in ice caps or even hidden under the surface. More and more things hint that Mars used to be habitable. Mars is the only planet we know about where only robots live. 5 rovers make up the Martian population. Those are Perseverance, Opportunity, Spirit, Sojourner, and Curiosity. These robots are there to take pictures and samples of soil and air, and maybe even find life on the red planet. And someday, we may reunite with them on Mars. Who knows? Oh, and by the way, if you really could get into a time machine and stop it 4 billion years ago on Mars, then I'd like to buy you lunch and talk about it. My treat.
Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown. 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer, and the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes, so it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction, and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid. And it would make for one epic light show.
So get this. Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, super-hot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space. We're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the Rosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the space intergalactic tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum.
Let's take a little satellite, tie it to the shuttle with 12 miles of cable, and send it for a spacewalk. It might sound like another crazy plot for a YouTube hit video, but this idea actually belonged to NASA. In 1996, they teamed up with the Italian Space Agency to try one of the boldest, strangest experiments ever attempted in orbit. The mission was called TSS-1R, short for Tethered Satellite System 1R. They came up with a plan to reel a satellite from the Space Shuttle Columbia on a tether that could carry an electric current. As the shuttle zipped around Earth, that long cable would slice through the planet's magnetic field lines. In physics terms, moving a conductor through a magnetic field generates electricity. So, the Space Shuttle Tether Satellite combo was about to turn into a giant orbital power generator. It was like plugging an extension cord into Earth's invisible magnetism. The physics behind this craziness was rock solid. Engineers hoped this tether would pump out usable power, maybe even thousands of volts. If it worked, it could change how spacecraft get electricity or inspire new ways of braking in orbit using electrodynamic drag. So, launch day came. Columbia lifted off. The crew prepared the system, and they started letting the satellite out on its long, long cord. At first, it was smooth sailing. The satellite glided away, the tether unreeled like a spool of cosmic fishing line, and the science team was buzzing with excitement. As the line stretched longer, it started generating more and more electricity, over 3,000 volts at its peak. Everything was running perfectly like a dream experiment. And then, just as the tether was almost fully extended, nearly the full 12 miles, things took a dramatic turn. A localized electrical discharge zapped through the tether's insulation. The cable arced and burned a hole right through itself, and with one fatal snap, the tether broke. Just like that, the grand experiment was toast. The crew could only watch as the little satellite, still trailing its dangling wire, floated off into space like a lost balloon on the world's longest string. Years of hard work preparing the experiment just literally drifted away. Visually, it was almost comical. Reporters couldn't resist calling it the goofiest space experiment in history, and honestly, they weren't wrong. It looked less like cutting-edge space technology and more like someone had tied a toy to a string and let it loose above Earth. But, goofy or not, the experiment actually proved the physics worked. Before the failure, the tether really did generate significant electricity, exactly as the scientists predicted. Over 3,000 volts coursed through that cable before it fried. The idea of using conductive tethers for power and propulsion in space wasn't a fantasy. It was all real. The problem wasn't the science, it was the engineering. Space is an unforgiving place, and one small weakness in insulation was enough to take down the whole mission. Even though TSS-1R ended with a literal snap, it left behind valuable data. Engineers learned more about how tether systems behave in orbit, and the concept is still alive today. Researchers keep looking at space tethers for everything from satellite deorbiting systems to futuristic power stations in orbit. So that broken cable might have been a letdown in 1996, but it wasn't the end of the story. If a satellite on a cable isn't wild enough for you, how about 2 golden orb weaver spiders on the International Space Station? In 2011, NASA sent these 2 cuties, called Gladys and Esmeralda, up there on Shuttle Endeavour, just to see, can spiders spin webs in microgravity? Turns out, yes. The experiment lasted 45 days. While floating in orbit, the spiders went ahead and spun webs, but the webs looked shockingly symmetrical, perfect circles, rather than the slightly lopsided webs they usually make on Earth. The spiders, deprived of down and up, used light inside their habitat to orient themselves. On Earth, spiders use gravity to guide how they stretch their legs and spin out their web lines. But in space, with no gravity to rely on, they looked at the lamps and used that as their ground. But that experiment in 2011 wasn't the first space adventure for spidernauts. Way back in 1973, NASA launched 2 female European garden spiders called Arabella and Anita into space aboard Skylab 3. The idea of this experiment actually came from a 17-year-old high school student in Massachusetts. The spiders were stashed in little containers and then coaxed into a special tank to spin webs while orbiting Earth. At first, Arabella struggled. She took a while to adapt, and the first web she spun was incomplete. But by the next day, she managed to finish it. Over time, the webs she produced were finer and more delicate than normal Earth versions, and scientists noticed subtle differences in thickness across the threads. But NASA wasn't just curious about spiders for the sake of, spiders. Scientists wanted to figure out how near microgravity messes with the central nervous system, not just in spiders, but in animals in general, humans included. Spiders actually make the perfect test subjects because their webs are basically brain maps in silk. You can tell how well the spider's nervous system is working just by looking at the shape and quality of the web it spins. On Earth, a spider has a whole toolkit. It knows how heavy it is, so it figures out how thick the silk needs to be. It uses wind and gravity to decide where to anchor and how to stretch the lines. But the way spiders adjusted to build webs in 0G gave clues about how our own motor systems and brains might behave if we had to live long-term in space. Sadly, Arabella and Anita, the first 2 spidernauts, did their job, spun webs, gave us tons of data, but didn't survive their mission. The likely cause was dehydration. On a brighter note, scientists have grown everything from lettuce to yeast on the ISS. But one of the oddest was trying to see if fungus could shield astronauts from radiation. They took samples of a fungus that thrives in places with high radiation and monitored how it reduced radiation passing through it. Over a thin layer of this fungal mat, radiation levels dropped by about 2.17% compared to a control sample. At the same time, the fungus had around a 21% growth boost in microgravity. So not only did it block some radiation, it actually seemed to use radiation to fuel itself, almost like a weird fungal solar panel. Now, you might ask, why fungi? Why not steel or lead? Because living things self-repair, self-replicate, and adapt. If you could grow stuff that helps shield you from radiation while it's doing other jobs like repairing and evolving, that's gold for long space missions. The idea is, maybe astronauts could grow part of their radiation shield using organisms, instead of hauling tons of heavy shielding materials into space. There was also broader research catalogs on space fungi and microbes. One study in 2019 cataloged all the bacteria and fungi found inside the ISS, on walls, equipment, windows, sleep stations, you name it. They found the fungal communities were pretty stable over time. That means fungi are not just surviving, but persisting in that closed, harsh space environment. This science experiment is like a hint that we could have a future where biology and engineering mash together. If we can harness fungi or other organisms as part of a spacecraft structure, we open up a whole new way of designing space habitats. Instead of walls you build once, you could have walls that grow. To make radiation levels Earth-like on Mars, you might need a 7.5-foot thick layer of this fungus covering a habitat. That's huge, but maybe easier than dragging tons of lead through space. There's a lot to figure out about safety, control, dose limits, and how this would work long-term. But in the future, astronauts might live behind walls of living mushroom shields, literally harnessing biology to survive the void. A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to Arxiv, which is where science nerds drop their ideas before they hit the big journals. And it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar. At least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie. Magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now, let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby: gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pawlowski had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pawlowski's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pawlowski thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Pawlowski's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved, without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang. Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush, because apparently precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Karman Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching. A huge invisible danger zone is hanging above Earth, messing with satellites, zapping electronics, and giving astronauts a headache. Scientists call it the South Atlantic anomaly, and it's kind of like the Bermuda Triangle of space, because weird stuff happens there and nobody fully understands why. Want to know more about this thing? Well, Earth has a magnetic field that protects us from dangerous radiation from the sun. We'll talk about it later. And over one spot on the planet, right above the South Atlantic Ocean, that shield gets weirdly weak. It stretches over South America and parts of Africa, creating a sort of magnetic soft spot. That weak spot is bad news for anything flying up there. When satellites travel through it, their systems can freak out. Computers freeze, data gets scrambled, and sometimes entire instruments shut down. Basically, the space version of your phone glitching out right when you need it most. Astronauts have to be extra careful in this region too. When the International Space Station passes through the anomaly, radiation levels spike. It's not enough to fry anyone, but it's surely not fun. The equipment can take a serious hit. No one knows exactly what's going on yet, but scientists think the SAA might be a clue that Earth's magnetic field is shifting. If that's true, it could mean big changes for the future, for us all. You see, the South Atlantic anomaly is connected to Earth's molten insides. Deep beneath the surface, the planet's core and mantle are constantly moving, flowing, and clashing. The outer core is a swirling ocean of liquid metal, and the mantle above is hot, solid rock. Under Africa, there's nothing to cool things down. The mantle is hotter than usual, which creates certain instability in the magnetic field above. As for South America, there, the Nazca Plate is dragging rock and debris down toward the core. This cools things off and keeps the field more stable. Such a wild temperature difference seems to be fueling the anomaly. According to some sources, it drives it across the Atlantic. The anomaly is slowly drifting westward. The thing is, Earth's magnetic field protects us from dangerous radiation from space, powerful solar winds, and wild swings in temperature, and keeps our atmosphere in check. But over millions of years, the magnetic poles have flipped. When it happens, north becomes south, south becomes north, and during those flips, the field can weaken. And some scientists thought the South Atlantic anomaly might be a warning sign before a full magnetic reversal. It could mean disaster to humans, but we'll talk about it later. The good news is, these flips take over. On average, Earth flips its magnetic poles about 2 times per million years. That means the next reversal could be hundreds of thousands of years away. Nearly 600 million years ago, our planet's shield almost failed, but at that time, it could have been a good thing. Scientists think this near collapse might have triggered a massive evolutionary boost and helped the first complex life forms to evolve. Back then, during a period called the Ediacaran, the magnetic field weakened drastically and stayed that weak for about 26 million years. With less protection, solar radiation removed lighter gases from the atmosphere, leaving oxygen floating freely in the air and oceans. That oxygen helped the first multicellular oxygen-breathing organisms to see the light of day. Those were strange, squishy creatures that hardly resembled animals today. Some were disc-shaped blobs, fronds, or shapeless fans, stretching over 3 feet long. By the way, one of the earliest known animals, Dickinsonia, was among them. It looks kinda pretty, doesn't it? Now, how do we know all this? Thanks to rocks. They're like time capsules. Tiny crystals inside them preserve the power of the magnetic field from hundreds of thousands of years ago. For example, certain crystals from southern Brazil revealed that 591 million years ago, Earth's magnetic field was 30 times weaker than it is now. And rocks from South Africa dating back 2 billion years showed that the field was at full strength back then. Now, let's explore a bit. Deep beneath our feet, there's Earth's inner core. We're used to thinking about it as a perfect solid ball, but new research suggests it might be changing shape. Over the past 20 years, parts of the inner core may have bulged or dipped by more than 300 feet. That's like a skyscraper popping up or sinking deep underground inside the planet. This core spins independently from the outer liquid core, which creates the magnetic field that shields us from dangerous solar radiation. The magnetosphere is non-negotiable. Without it, Earth would lose its atmosphere over time. water would vanish and life as we know it wouldn't survive. It basically keeps the planet alive. Without it, Earth could turn into a barren Mars, which lost its magnetic field billions of years ago, and along with it, almost all its atmosphere. So why is our planet's inner core deforming? It seems to happen where the solid inner core meets the super hot liquid outer core. The molten metal flows around it, and combined with the tug of an uneven gravity field, likely warps its edges. Scientists can't drill down to the core to check this theory. It's 3,200 miles below the surface. But they can track seismic waves from earthquakes as they ripple through Earth. They measure how these shock waves bend, slow down, or speed up, and it can help figure out what the inner core is made of and how it moves. That's probably how they know that the solid inner core is slowly growing, freezing layer by layer of the liquid outer core. But don't worry, it'll take billions of years to fully solidify. By that point, life on Earth would probably already be gone anyway. The sun's gonna swallow our planet long before the inner core stops moving. But let's get back to the topic that, I bet, worries you most. What if Earth's magnetic field just vanished one day? Well, the planet would be hit by a storm of charged particles from the sun. Satellites would start glitching and power grids would go down. We would get zapped with higher levels of UV radiation, the kind that can cause all kinds of serious health issues. In short, it wouldn't be instant doom, but life would get a lot trickier. Luckily, now we know that a magnetic field doesn't just vanish overnight, but ours has been slowly weakening for over a century. So what would life on a planet with a super weak magnetic field look like? You would just have to throw away your compass. It wouldn't point north anymore, just towards the nearest patch of strongest magnetism, wherever that may be. The northern and southern lights would go insane, appearing closer to the equator, all because charged solar particles would be able to get through the atmosphere more easily. Satellites would be under constant attack. Solar particles would fry their electronics, mess with memory, and cause what scientists call single event upsets. High-frequency radio signals would also get scrambled, thanks to free electrons in the ionosphere. Over time, the solar wind could even start wearing down the ozone layer, leaving us all more exposed to UV radiation. Now, let's decrease the level of drama. A magnetic field isn't the only thing keeping a planet alive. Mars did lose its magnetic shield about 4 billion years ago, and most of its atmosphere got blown away. But Venus has no global magnetic field, but still has a thick atmosphere. If Earth lost its magnetic field completely, we wouldn't instantly vanish, but life would definitely change, and we would have to get used to these drastic changes.
Just when you think space couldn't get any more weirder? Hey, check my grammar. The universe throws a curveball in the form of a giant glowing bubble that's too perfect to be real. Astronomers have spotted something strange drifting through our galaxy. And it's not a rogue planet, which is a space body the size of a planet that doesn't orbit any star. It's not a star itself either. It's not even your average supernova remnant. It's a perfectly round sphere, and scientists are stunned. Astronomers were going through data from a super powerful radio telescope when they spotted something that looked like a perfect round bubble. At first, they thought it was the leftovers from a massive star explosion called a supernova. But the weird part was that the object was too perfect. Normally, such explosions leave behind messy, uneven clouds. And the newly discovered one looked like someone had drawn it with a compass. The scientists named the space bubble teleios, which means perfect in ancient Greek. They've already looked at all the possible explanations, but none of them really make sense yet. This strange space body was discovered thanks to a telescope in Australia called ASCAP. It's been scanning the sky and finding all kinds of weird circular objects. This research was part of a project called the Evolutionary Map of the Universe. Some of the faraway circles, known as ORCs, which is short for odd radio circles, have already puzzled scientists. But this one is different because it's inside our own galaxy. At the same time, even though Teleos is technically closer to us, scientists can't quite figure out how close it is. And that's making it harder to understand where it came from or how it formed. The researchers have taken an even closer look at this strange space bubble and found something super odd. It only gives off a very faint glow and only in radio waves, not in visible light or X-rays. Based on that glow, they figured it's most likely the leftover shell of a massive star explosion called a Type Ia supernova, one of the brightest and most powerful kinds of explosions in the universe. This kind of explosion happens like this. A super-dense dead star, called a white dwarf, starts stealing material from a nearby star. It keeps sucking in stuff until it just can't handle the weight anymore, then it blows up in a huge burst of energy. Now that part makes sense. But figuring out how far away is this thing? Strangely, it's not so easy. Scientists have run the numbers and ended up with two possible distances for Teleos. Either it's around 7,175 light-years away, or it's much farther, about 25,114 light-years away, give or take. Depending on which distance is right, the size of the bubble could be vastly different. If it's closer, then it's about 46 light-years wide. That would make it a pretty young supernova remnant, maybe less than 1,000 years old. But if it's farther away, then it's a giant 157 light-years across, which could be more than 10,000 years old. So, which one is it? That's where things get tricky. Scientists have models that tell us how these supernova leftovers should behave. And one of the most important things they expect to see is X-rays. But you might remember that Teleos doesn't show any, not a single X-ray in sight. That's the big mystery. How can something that should be glowing with X-rays be totally silent? It just doesn't add up and leaves the scientists very puzzled. Another idea the scientists are considering is that Teleos might not be a regular supernova remnant at all. Instead, it might be the leftovers from a rarer kind of explosion called a Type Lax supernova. And this one? It's extra weird. In a normal Type La supernova, the white dwarf star blows itself to bits. But in a Type Lax supernova, it doesn't get totally destroyed. It kind of survives, turning into a zombie star. Ooh. It's damaged, but it's still around. This would actually explain a lot about how Teleos looks and glows. But in this case, it would have to be much closer to us, only about 3,262 light-years away. That would also make it a lot smaller, about 11 light-years wide. The coolest thing here is that there's actually a star at that distance that could be the zombie star that caused all this. But, and it's a big but, like I have, when scientists use other ways to try and measure how far away Teleos is, none of them agree that it could be this close. So, sadly, this theory hits a bit of a wall. Then there's another strange thing. Teleos' nearly perfect spherical shape. That's not normal. Usually supernova explosions are kind of messy and uneven. The blast might push into clouds of space dust or gas, or parts of the explosion might move faster than others. Eventually, the shell that forms gets all lumpy or starts to break apart. But in this case, the object is almost perfectly round, like a balloon, and that's super rare. The only way something could stay this neat and round is if it exploded in a very empty part of space and expanded smoothly in all directions. That's actually not impossible, just really, really rare. Now, considering its unique, probably unnatural shape, could Teleos be an artificial object? Could it be a Dyson sphere? That's a hypothetical megastructure that could completely surround a star and harvest all of its energy. At first, this idea was supposed to explain how we might detect intelligent extraterrestrial life by spotting the energy they use rather than waiting for them to send us a message. You see, here on Earth, we only receive a tiny bit of the sun's energy. Meanwhile, a whopping 386 billion megawatts are shooting out into space in all directions. Not to waste such a giant amount of energy, a civilization could build a Dyson sphere, or more realistically, a Dyson swarm, loads of solar panels orbiting the star. It would help them capture every bit of that power to run their planet, technology, AI systems, and maybe even space travel across galaxies. To understand just how advanced a Dyson sphere-building species would have to be, scientists use the Kardashev scale. It ranks civilizations by how much energy they can use. Type 1 can use all the energy available on their home planet. Spoiler, we're not even there yet. Type 2 can harness all the energy from their star. That's the Dyson sphere level. Type 3 can use energy from an entire galaxy. Think Dyson spheres around every star and even extracting energy from black holes. Right now, Earth's civilization ranks about type 0.7449, give or take. That means that we haven't even maxed out the energy available to us on Earth, including fossil fuels, renewables, and nuclear power. We're still taking baby steps on this cosmic scale. Anyway, the problem with the theory that our perfectly shaped object could be a Dyson sphere is that this example of super advanced technology would give off heat. In other words, there would be thermal infrared radiation, and the object would be unusually bright in the infrared. This could be a sign that something artificial is absorbing the star's energy and re-emitting it as heat. But the scientists have found no heat signatures or anything like that when observing Teleos. So, do we have the final answer? Not yet. The scientists have looked at all the existing clues, how bright the thing is, how big it looks, and how far it might be, and none of the possibilities are totally perfect. Each idea has a problem, especially the fact that we're not observing any X-rays, which should be there according to the usual rules. They still think that regular type LA supernova idea is the best bet for now, but they're not 100% sure. There's just not enough proof to say for certain. So, the mystery continues. The team says we'll need more powerful and detailed observations to really figure out what happened here. But in any case, if something like Teleos can exist, what else is out there, waiting to challenge everything we know about the universe? So this thing, Cosmos 482, a high-tech capsule, was built to survive even the most extreme heat of another planet. But something went wrong. It never made it out of Earth's orbit. For over 50 years, it drifted silently around the planet. Forgotten until now. In May 2025, gravity finally pulled it down. It's coming home, built to survive re-entry and unpredictable enough to crash anywhere. No warning, no parachute. Just a 1,000-pound sphere falling from the sky, a human-made meteorite capable of causing chaos. In 1972, this funny-looking ball was sent on a Venus-bound mission. Now, Venus is like Earth's evil twin. It's similar in size, but that's where the similarity ends. It's the hottest planet in the solar system, where temperatures reach 860 degrees Fahrenheit, hot enough to melt lead. Atmospheric pressure is about 93 times greater than Earth's, which is like being 3,000 feet underwater and you feel like you're in a trash compactor. And the atmosphere itself is made of carbon dioxide, with clouds that literally rain sulfuric acid. So yeah, it's pretty bad. Yet Cosmos 482 was fully expected to reach it and land. Not for long though. A type of self-destruct scouting mission. The spacecraft was designed to land and transmit data, hopefully for at least a few minutes, on the surface that crushes, bakes, and basically dissolves anything that touches it. How? Well, it came with heat shields for the fiery plunge, a mini AC to cool just long enough, and armor tough enough to handle Venus's brutal environment. It was truly a high-tech reinforced vault built for a one-way trip. And this was in the early 70s, mind you. Fun fact, even today, we've never built anything that could survive that kind of environment. We have deep-sea submersibles that can handle big-time pressure, but not the heat. There are space capsules that can withstand extreme temperatures, but only for a few minutes. Even nuclear reactor walls, designed to handle serious pressure, would crumble if acid rained on them nonstop. Now, a funny twist of this story is that landing on Venus was already achieved in 1970. Venera 7 became the first spacecraft to land on another planet and transmit data back to Earth, surviving on Venus's surface for a full 23 minutes before melting down. It proved the impossible was possible. just not for Cosmos 482. So, what went wrong with Cosmos 482? We've always imagined space travel as firing up the spaceship, launching it, and that's it. However, that's not how it works. First, with an initial boost, you park it in Earth's orbit, like pulling into space's driveway. Then comes a second burn, a precisely timed engine firing that pushes the spacecraft out of orbit and toward its destination. Cosmos 482 made it to the parking orbit just fine, but something went wrong with the second push. No push means no trip, so instead of heading to Venus, it got stuck circling Earth for the next 50 years. But why does something get stuck orbiting for so long? Well, when something gets launched into space, it's not just going up. It's also going really fast sideways. If you throw a baseball up hard enough, it'll eventually hit the ground. But if you could throw it fast enough and Earth wasn't in the way, it would just keep falling around the planet. That's what orbiting means, falling but never hitting the ground. The object's forward speed balances perfectly with the gravity pulling it down. So, to leave Earth, a spacecraft needs to pass through 3 layers. The first is low Earth orbit, or LEO, a few hundred miles up. Here is where satellites, the space station, and tons of leftover junk circle the planet. Cosmos never made it past this point. If the second launch had been successful, it would have gone through medium Earth orbit, where GPS satellites cruise. Then, way out at 22,000 miles, there's geostationary orbit, the sweet spot for weather reports and TV. So now we know how Cosmos ended up there and why it was orbiting for so long in LEO. But what made it suddenly change its mind and fall back? Even in LEO, space isn't completely empty. There's still a tiny bit of atmosphere up there, and over time, it acts like a brake, slowing things down just enough. Think back to that baseball you threw sideways fast enough to orbit Earth. Eventually, it will slow down to the point where gravity takes over. However, Earth is securely protected by its atmosphere. As objects fall back to Earth, their speed keeps increasing up to tens of thousands of miles per hour. When you're moving that fast, the air pushes back really hard. That push creates friction, and friction creates heat, a lot of it. The surface of falling objects can reach over 3,000 degrees Fahrenheit, causing them to melt, shatter, or vaporize completely before they ever hit the ground. That's why scientists don't lose sleep over small debris. Small pieces of old satellites, even tools lost during spacewalks, fall all the time. But they burn up like shooting stars. We just never notice them. Now, a baseball would disintegrate instantly. But what about a giant ball designed to withstand landing on Venus? Thankfully, this potentially horrifying story is anticlimactic, because Cosmos crashed into the Indian Ocean west of Jakarta on May 10, 2025. Radar picked it up streaking through the sky, glowing, breaking, heating up, but still intact enough to make it all the way down. And it did, thankfully, not somewhere crowded. However, now that it's lost beneath the waves, we are free to speculate. How real was the danger? Could it have fallen into a crowded area? Absolutely. If that 1,000-pound capsule had come down over a city, it could have smashed through rooftops, wrecked cars, or worse, seriously injured someone. And no, there wouldn't have been sirens or alerts. Cosmos 482 was launched in the 1970s, long before GPS or live tracking, so there was no signal to follow, no proper guidance system. Scientists could only make rough estimates about where it might land, so if it had come down over land, it would have looked like a meteor. Well, the story of Cosmos, with the K, had a happy ending. But it's not the only thing up there that could fall down. As of early 2025, about 11,700 satellites are active. But with roughly 14,900 in orbit, that means over 3,000 are no longer operational. And the space junk keeps piling up. Space tracking systems monitor more than 40,000 objects that are bigger than a softball, such as pieces of old satellites and bits of rockets. Scientists estimate there are over 1 million fragments larger than a half an inch, and more than 100 million smaller bits still floating around. These can't hurt us down on Earth, but most of it clutters LEO, where collisions can generate explosive clouds of debris, damaging satellites and space stations. Just one crash can trigger a chain reaction called Kessler syndrome, where each impact creates more debris, leading to more collisions until Earth's orbit turns into a demolition derby. Remember the movie Gravity? Yeah, like that. And yes, bigger things from Leo do fall. Cosmos 482 wasn't the first space object to come crashing back. In 2016, Tiangong-1 space station lost contact and tumbled back to Earth 2 years later, eventually burning up over the Pacific. In 2001, the famous Mir station was intentionally brought down. And before that, in 1991, Salyut 7, another space station, unexpectedly deorbited. The 40-ton station broke up on re-entry, and parts that survived scattered over Argentina. Among others, in 1979, NASA's Skylab, the very first American space station, fell back to Earth with only partial control. Pieces of it rained down across Western Australia. Some newspapers even offered cash rewards to anyone who found a chunk. So, we've seen this happen before. Cosmos was just the latest reminder. But NASA and other space agencies do think about this problem. And most modern spacecraft designed to return have parachutes, heat shields, and built-in safety systems to guide them home. But not working satellites and old junk. Yeah, they're still up there. So next time, a space object might not land safely in the ocean. It might crash through your roof while you're watching a Brightside video. But don't worry.
In 2023, an ex-NASA engineer claimed he built a machine that can lift itself against gravity without using any fuel. No rockets, no fire, no exhaust, just electricity. If true, it would break the most sacred laws in physics and rewrite everything we know about space travel. So, is this just another hoax or a door to the future? The engineer's name is Charles Bueller. He used to work for NASA, making sure rockets don't blow up randomly. He was a part of the Space Shuttle, Hubble, ISS, and other huge projects. Now, Bueller and his team work at a private company called Exodus Propulsion Technologies, trying to build a long-term dream of space engineers, a spacecraft that doesn't need fuel. It's the kind of thing that would instantly change everything about space travel. Just think of the future where you could go to the moon, Mars, or wherever you'd like without spending tons of resources. And he claims that he and his team have finally cracked the code. That they've built a machine that can lift itself in the air without any propellant. You got it right. The team claims to have violated Newton's third law, the basic rule of our world that every action needs an equal and opposite reaction. For example, in rockets, you throw fuel out the back, that's action. Being pushed by it, the rocket goes forward. That's the reaction. A magical device like that would also violate the conservation of momentum. When you push on something, you gain momentum, but something else has to gain equal momentum in the opposite direction to balance the books. But this device would change the total momentum of the system out of nowhere. If you're getting motion without pushing against anything, how in the world did you do that? It's like a balloon that can somehow move forward without blowing out any air. If the machine actually works, there must be some new, unknown force of nature that we've somehow missed in hundreds of years of physics. Bueller himself called it the new force. Let's try to figure it out. To create this magical device, they used electrostatics. Their test device was little, a 30-gram object about the size of a card deck, and it managed to create thrust or push using electric fields, a kind of invisible force made by electric charges. The new force starts working when two things happen in the system. The first one is electric imbalance. There's some electric pressure happening across parts of the device, kind of like air pressure. If it's not spread out evenly across it, for example, one side has more electric push than the other, that's the first ingredient. And that happens when the electric field, the invisible force that electric charges create, is set up just right. It has to spread out in a certain way, not in straight lines, but uneven and fanning out, like sun rays or the spokes of a wheel. And boom, when it happens, the device pushes on itself and makes the whole object move. At first, the mysterious new force was tiny, barely noticeable, little to no thrust and noise. But with each upgrade, things started to shift. And in 2023, they finally measured enough thrust to overcome Earth's gravity. The weirdest part is that, according to Bueller, in some cases, the thrust keeps going even when the power is off, as long as there's still charge left in the materials. That's weird. That's really weird. That hints at something totally new in physics, something deeper than we currently understand. So now, any honest scientist starts sweating, because that sounds bananas, and frankly, it might be. Bueller admits this is still early work. The team published their discovery and got a patent. By the way, the company includes people who've worked at NASA, Blue Origin, and the US Air Force. They've been tinkering with this stuff for decades. Charles presented his findings at APEC, a conference for people who are passionate about alternative propulsion and crazy stuff like warp drives, anti-gravity, and ways to make Star Trek real. Now, they're actively working on that project. Of course, this stuff got very controversial, and lots of scientists are skeptical. There might be a mistake no one has caught yet, so they want to test the machine in space. If it works out there too, it could change space travel forever. It might be real, because it's not the first time we've discovered something like this. Recently, a startup called Evo Limited claimed that they'd built a quantum drive, another propulsion device that apparently didn't need fuel. They said they're tapping into a weird controversial theory of physics called quantized inertia. It was cooked up by a British physicist named Mike McCulloch. He basically said that inertia, the thing that makes objects resist acceleration, isn't a basic rule of nature, but an effect caused by some weird quantum radiation at the edge of the observable universe. In simple words, if QI is right, then under the right conditions, you might be able to generate thrust without throwing anything backward. You don't need fuel, just electricity and a clever enough setup. Many scientists don't buy into it, but who knows? Maybe that's why these new inventions could actually work. Anyway, initially, the IVO company was founded by a small team of tech guys who wanted to find wireless power. Their first big idea was called CBAT, capacitive-based aerial transmission. Basically, a fancy way to wirelessly send electricity through the air. But somewhere along the way, they pivoted. They started wondering, if we can move electricity through the air like this, can we move objects too? Can we rethink inertia itself? So, in 2021, they began working on a propulsion device based on this quantized inertia theory. They built the quantum drive around this idea. It was a self-contained electric system. No fuel tanks, no combustion, just a plug-and-play box that makes spacecraft move. They said it's light, stackable, and can be bolted onto a satellite like a toaster. And it weighs just a few hundred grams, way lighter than traditional thrusters. In 2023, they tested it, not in someone's garage, but in a legit vacuum chamber, simulating space conditions. The team said they ruled out every known force that might explain the results, and that it did generate thrust, not a lot, but consistent and measurable. Then came the big moment. IVO and a partner company, Rogue Space Systems, launched the quantum drive into space, and now they're waiting for the results of the tests. A lot of physicists think it's all nonsense. Some of them notice that this stuff is impossible because they'd be perpetual motion machines. Basically, if a device like this actually worked, you could use it to make infinite energy, which violates the first law of thermodynamics. But IVO says they're not doing that. They say QI works within our normal Newton's laws, just a bit differently. Anyway, all this stuff needs double-checking. Skepticism is so right because a lot of people get some unpleasant flashbacks. In 2001, a British engineer named Roger Scheuer introduced the M drive. It was this weird cone-shaped device that supposedly created thrust without pushing anything out the back. People were super excited. NASA even tested it with their EagleWorks team, and in 2016, they said they've detected tiny amounts of thrust from the M drive. The media absolutely blew up. People and scientists were hyped up, but later, bigger studies, including one from a German university that really went deep, found the sad result. It was just an experimental error. By 2021, the verdict was in. The M drive didn't work. It was all experimental noise, misunderstood data. Another dream went down the drain. Many propellantless designs have crashed into one huge stubborn wall, the laws of physics. So it's too early to say that these startups just change the world forever, but if it turns out to be real, it's not just a new engine, it's a new era.
So, you wake up after a nap. You flick the light switch. Nothing. It's still pitch black. Your phone battery's gone. The charger's useless. No Wi-Fi, no TV, just static on the radio. You are completely cut off. You move to the window and see that the entire city is in darkness. Then, out of nowhere, the night sky explodes into swirling shades of green, purple, and blue. It's an aurora borealis in a place where it should never happen. So, what's going on? What sounds like a real modern-day nightmare might come true if a super powerful solar storm hits Earth, and it could cost trillions of dollars in the United States alone. So now scientists are building some kind of warning system. It's a space traffic light, helping to protect us from the hidden dangers of our own life-giving sun. Now, first things first, solar storms are giant bursts of energy that come from the sun. Imagine the sun as this big sphere, wrapped up in a chaotic mess of magnetic fields, just like your fine strands of hair after a rough night's sleep. Now, as the sun spins, those magnetic fields start to twist up. But here's the thing, they don't all move at the same speed, and that's what throws everything off balance. Because those tangled magnetic fields get stretched and twisted so much that they eventually snap and reconnect. And when that happens, boom, tons of energy gets released and races through space. A solar storm is exactly that, a sudden outburst of energy, particles, magnetic fields, and hot material thrown out by the sun. And it usually shows up in three powerful forms. First up, the solar flare. This is a bright flash of radiation or light that puts on a spectacular show. These are the most powerful explosions in our solar system. Solar flares send out all kinds of energy across the electromagnetic spectrum, including X-rays, gamma rays, and radio waves. Next, the radiation storm. This happens when the sun launches charged particles, like electrons and protons, into space at super high speeds. Just to give you an idea, the quickest particles can cover the 93 million miles from the sun to the Earth in just 30 minutes. And finally, the coronal mass ejection. This is when massive clouds of plasma explode from the sun's outer layer, known as the corona. From afar, it looks like giant bubbles popping off the sun's surface. These blasts are so strong, they can shoot billions of tons of material deep into the solar system in one powerful burst. Okay, so solar storms are blasting all this stuff out into the solar system. And that should be fine, except it's not, because it can affect us. When a solar storm is headed toward Earth, things can get tricky. If it slams into our magnetic field, it triggers what's known as a geomagnetic storm, and that can seriously mess with our daily lives. Take satellites, for example. A strong geomagnetic storm can damage them or make them shut down for a while. GPS systems, like the one in your phone or car, can stop giving accurate directions. Signals from TV might glitch or cut out. Even phone calls could drop or sound weird. On a larger scale, the internet itself could run into serious trouble. If service providers go down, all the systems that rely on the web to stay connected might stop talking to each other. That could leave countless people and businesses completely offline. Experts say this kind of internet apocalypse scenario could cost anywhere from $600 billion to a staggering $2.6 trillion in damages. And that's just in the United States alone. Radio communication might also take a hit, and that's a big deal, because during a major blackout, it's usually one of the few ways we can still get news. But the trouble doesn't stop there. It can also mess with flights all around the world. And for everyday people, that could mean grounded planes, delayed trips, and total confusion at airports. It can also send extra electrical current flowing through power lines. That sudden surge can overload transformers and knock out the power. This isn't just a what-if situation. It really happened in Canada back in 1989, for example. A solar storm left the entire province of Quebec plunged into darkness for 9 hours straight. Although powerful solar storms don't hit Earth often, they can and do happen. In fact, one struck in May of 2024. You might remember the news. Social media was flooded with photos and videos of strange auroras lighting up the sky in shades of green, red, and blue. But the wild part is that these auroras showed up in places where they're not supposed to. People in countries like Brazil, South Africa, Turkey, South Korea, Spain, and many others got to see this stunning sky show for the very first time in their lives. And all of that happened because of a solar storm, the Gannon storm. Yep, when a solar storm is strong enough, it pushes the auroras far beyond their usual zones, making them visible in places much closer to the equator. Now, although they're still considered rare, powerful geomagnetic storms are happening more and more often. That's because the sun is experiencing what's called the solar maximum. Basically, it's a peak in solar activity that happens about every 11 years. So, when's the next big solar storm going to hit us? Well, maybe soon. NASA says an event like that could happen sometime in 2025. It might strike next week or maybe a few months from now. But here's the tricky part. No one knows exactly when it will happen. It's tough to predict it because the sun is complex and always changing. So there is a lot of uncertainty around the speed and direction of solar storms. That's why we've got satellites floating about 1 million miles from Earth just to keep an eye on them. But here's the problem. When a big solar explosion happens, it can reach Earth in just 1 day. And since our satellites are still pretty close to us, we only find out the important stuff, like the direction of the magnetic blast, perhaps only an hour before it hits. And that's barely any time to act. It makes it super hard to prepare and protect things we rely on every day, like power lines, internet service, phone networks, and satellites flying above us. So today, we're just hoping for the best. And that brings us back to why we need a traffic light system to protect us from solar storms. The main goal of the Pager project is not to predict when the storm might hit, but also to understand how bad it could be and what kind of damage it could cause here on Earth. This traffic light will be an algorithm. It will collect information from telescopes watching the sun and from satellites orbiting Earth. Then it will feed that data into advanced models. These models can predict how much radiation is in space, how it might affect spacecraft, and what kind of impact it could have down here on the ground. This will also help satellite operators decide if space conditions are safe or not. Just like your local weather forecast tells you if you might need an umbrella. This system will do the same for satellites, warning them when it's better to power down or stay protected. But the main idea is that this tech could give us a heads up way earlier about dangers coming from the sun. With these traffic light calculations, we might know when a solar storm is coming and how strong it will be up to 2 days in advance. That's a big deal, because this will finally give us a chance to be better prepared for the next one. This signal had been traveling through space for 200 million years, and now, when it finally reached Earth, it brought a fascinating story with itself. It might even help us solve an 18-year-long mystery. We caught this one in 2022. It was such an intense burst of radio waves. Even though it lit up for a fraction of a second, it outshined entire galaxies. At first, this signal hasn't caught attention because we've seen similar things before. It was a fast radio burst, or FRB for short. These guys have been a mystery for years now, all because we have no idea where they come from. Now, FRBs are brief booms of energy, coming to us from all over outer space. They're barely catchable, lasting up to 3 seconds. But they're also very hard to miss, because their power is absolutely unimaginable. One little burst can release as much energy as the sun does in an entire day. They've been a puzzle for us ever since 2007. We've caught over 1,000 of those signals from literally everywhere, from our own galaxy to places as far as 8 billion light-years away. And none of them revealed where they're coming from or what they mean. At least we know they're not from extraterrestrial creatures. They have to be coming from something that happens nearly constantly, and this recent signal might finally help us learn the truth. It lasted about 2 milliseconds, and it wasn't particularly bright. But when researchers took a closer look, they realized they can actually finally track this one. They got to it immediately. They saw that the burst came from a galaxy about 200 million light-years away. In other words, this is exactly how long these radio waves have been traveling to us. The signal flickered in a weird pattern. This is what we call a scintillation. When light or radio waves travel to us, they can stumble upon unexpected crazy clouds of gas. The particles in light waves start bouncing off this gas, which disturbs the signal a little bit. So when we received it, it was a bit weird and distorted, kind of like me. But this exact cloud was what helped us locate where exactly this signal came from. Turns out, it came from a neutron star. Now these are some fascinating guys. They're the remnants of stars that live fast and burn bright. When a powerful star like this, much larger than our Earth, runs out of fuel, it can no longer support its weight. So it goes away with an insane spectacle called a supernova. During its last moments, its core collapses under its own super-strong gravity, and this creates one of the densest objects in the universe. Again, a lot like me. Hey, what can I say? For curiosity, let's compare it to osmium, the most dense element on our planet. If you had a small cube of osmium, it would weigh around 0.8 pounds. That's already pretty heavy, and it means that 1 cubic foot of osmium would weigh a shocking 1,410 pounds. That's like an average cow. Now, just try to guess how much a small cube of neutron star would weigh. Wrong. It would be a horrifying 7 billion tons per one little cube. Don't even think about holding it in your hand. That thing would warp the fabric of reality around it. It's kind of like trying to imagine Mount Everest being squeezed into a tiny ball. Hard to even imagine. So even though they're so heavy, these stars are surprisingly small, only about 6 miles in radius. That's like a city size, and it would still weigh more than our sun. But if that's not enough horror for you, the neutron star we're talking about wasn't your regular one. It was a magnetar. Now, magnetar is a rare type of neutron star. When a neutron star is born, there's only a 10% chance that it will become one of those guys. It can happen if, while the star is collapsing, its magnetic field grows wildly stronger. The spin is rapid, the insides are going wild, and boom! We've got a magnetic field 1 trillion times stronger than Earth's. More than that, these are among the most extreme magnetic fields in the entire universe. They can literally rip atoms apart. Which is exactly what they do. They just rip everything apart. So they end up being surrounded by a super hot, electrically charged soup of particles called plasma. The magnetic field is going wacky, twisting, and bending the plasma as it sees fit. And this all just ends up as an ultra-hot party. Everyone is constantly colliding, scattering, and being absorbed. Not the best place for a hangout. Now, back to our main character. The magnetar in our story also had a plasma soup and a terrifying invisible field surrounding it. And this is exactly where that mysterious signal came from. A signal was born somewhere in that place, at a distance of 6,200 miles away from the magnetar. Sounds like a lot, but that's a distance shorter than a flight from New York to Singapore. But this is very weird, because How can a radio burst even escape a place like that? Now, usually they'd end up being blocked or absorbed. Most often, radio waves end up hanging out there like in a cage. This one, however, managed to break free somehow, which means that something happened that punched through the plasma. Energy somehow goes goofy, twists and reshapes itself in such ways that it starts releasing radio waves. Now, in any case, this means that FRBs most likely come from neutron stars and various types, like magnetars or pulsars. Recently, astronomers made a new amazing telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a mouthful. This one detects FRBs literally every day. FRBs are full of surprises in general. In the same year, we discovered an FRB with periodic peaks lasting over 3 seconds, much longer than typical bursts. This one could also come from a neutron star. But if it was just neutron stars, we wouldn't probably receive them all that often. It looks like these signals are very diverse and might actually be born from all sorts of places, like near black holes. So there are some other theories about their origin. For example, they could come from two stars smashing into each other. What could be more epic than that? A collision of two stars would release unimaginable energy, and they destroy each other completely. Uh-oh. Some astronomers think they could explain FRBs, but of course, that's not something that happens often at all. Also, FRBs sometimes repeat. Most of them flash once and disappear, but sometimes they almost flicker like the one we discussed. Some of them even follow very precise patterns. For example, one well-known repeater follows a 16-day cycle. It goes crazy for about 4 days and then goes quiet for 12 days before starting again. This one is hard to explain even with neutron stars. There has to be some unique astrophysical mechanism at play. Maybe something that orbits something else. But anyway, a star's collision would only explain signals that flash once and never again. Another possibility is the blitzar. It's a goofy name for a very dramatic idea: a neutron star turning into a black hole. Once again, an event like that unleashes a huge burst of radio waves. But, again, an occasion like that would be incredibly rare, and the signals aren't supposed to repeat. Black holes themselves are a pretty good option, though. They're central to many FRB theories. Could these bursts come from a neutron star falling into a black hole? Or from a collapsing black hole itself? Maybe even dark matter interacting with a black hole? Hey, who knows? Let's just throw all the ideas in there. Of course, the thing that everyone's most excited about is extraterrestrial civilization. Maybe not all of these bursts, but at least some of them could be signals from our intelligent neighbors. But like we said, that's very unlikely, considering that the signals come from all over the sky and many different distances. Also, almost all of them are the same, and that would be super hard and weird from an intelligent civilization to try and reproduce. Though who knows what else we might discover in the future. You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior. when they receive tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces. And this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas too, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small, non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny. But it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.